Yes, it's grade 10. Given r is equal to the square root of 2x plus 6 over 2x minus 6, for which value of x will r be undefined? Do we know, guys, which value of x? These are very common questions which needs your understanding of numbers. For which value of x will r be undefined? Look at the radical. R is equal to the square root of 2x plus 6 over 2x minus 6. So firstly, we need to understand what do they mean. They say for which value of x will r, what is r? R is the square root of 2x plus 6 in the numerator over 2x minus 6 in the denominator. So when they say for which value of x will r be undefined, what you need to clarify for yourself is, what does undefined mean? So undefined is when you have a fraction, and in this fraction you have what in the denominator? You have 0 in the denominator. Any number divided by 0 is what we call undefined. Okay, any number divided by 0 is undefined. That's what we call undefined. So let's go back to the question. For which value of x will r, what is r? R is the square root of 2x plus 6 over 2x minus 6. So we are asking which value of x here will r, meaning this entire expression, be undefined. So our attention then is what? It is the denominator. Our attention will be in the denominator. Our attention will be here in the denominator. And what are we trying to say here in the denominator? Were this fraction to have in the place of 2x minus 6 0, then this entire r will be undefined. So we want the value of x for which value of x will r be undefined. So please guys, whenever they talk about undefined, your mind needs to go back to the concept of any number divided by 0. In a fraction, a 0 denominator means undefined. Division by 0, a number divided by 0 means undefined. So if we come here to for which value of x will r be undefined, we are going to specifically put our attention on the 2x minus 6, which is where? In the denominator. And what are we going to do to the 2x minus 6 in the denominator? We are going to take that 2x minus 6 and we are going to say it is equal to 0. Why are we saying 2x minus 6 is equal to 0? It is because, let's go back, we were given r, which is equal to the square root of 2x plus 6 over 2x minus 6. And then the question asked, what value of x will this r, what is r? R is the square root of 2x plus 6 over 2x minus 6. So r has a numerator, which is 2x plus 6 underneath the square root. It also has a denominator, which is 2x minus 6. But then they want us to find the value of x. What is the value of x by which r will be what? Undefined. What does undefined mean? Undefined means any number divided by 0. In a fraction, whenever we have 0 in the denominator, we say that particular fraction is what? It is undefined. So that is why when we look at r, our attention, our focus is on the denominator. Why? The focus is on the denominator, and if the denominator were to be 0, then it would mean that r is undefined. What do we want? We want to know what is the value of x which will make this denominator become 0, so that r is what? Is undefined. So what do? We take the 2x minus 6, which is the expression in the denominator, and what do we do to it? We make it equal to 0. And then what do we do after that? We solve for x, which should be quite simple for a grade 9 learner who is now in grade 10 wanting to do pure maths, because to solve for x where 2x minus 6 is equal to 0 is simple. That way we'll be able to know what is the value of x by which r will be undefined. So we take 2x minus 6, make it equal to 0. Should be quite straightforward, right? According to last year, grade 8 and 9, we isolate x. Minus 6, we transpose to the right hand side. What happens when minus 6 gets transposed to the right hand side? When minus 6 gets moved to the right hand side, then negative 6 becomes what? Positive 6. Then thereafter, what happens? We divide both sides by the coefficient of x. In this case, what is the coefficient or the number next to x? It is 2. 2 has a relationship with x of multiplication, so we divide by 2. But remember, what we do on the left, we do where? On the sweet right. And then what do we get as the value of x? X is equal to what? What is 6 divided by 2? It is 3. So let's go back to the question. This question says given r is equal to the square root of 2x plus 6 over 2x minus 6. And then it said, for which value of x will r, what is r? The square root of 2x plus 6 over 2x minus 6. For which value of x will r be undefined? What does undefined mean? Remember, we said undefined means any number divided by 0 we know will be undefined. All right. So therefore, we know that our attention then to find the value of x that will lead to r being undefined means that we need to take this 2x minus 6 in the denominator, because our attention is what value of x do we need to substitute in the denominator to make the denominator become 0, because that will mean r then will be undefined. So we need to find that value of x. So we take what's in the denominator, equate it to 0. So 2x minus 6 in the denominator equal to 0. We then do what? We solve for x. When we solve for x, we get x is equal to 3. Alright. Now, if we take that 3, we substitute it in the denominator. What's 2 times 3? That is 6. What's 6 minus 6? That gives us 0. That will mean that when x is equal to 3, that is when this r becomes what? Undefined. Because that's how we make the denominator become 0 when x is equal to what? To 3. Okay. Guys, I hope this makes sense. All right. So yes, grade 10s, but you know, not just for grade 10. This is important for grade 11s and grade 12s, because I've found that grade 10s, 11s, and 12s don't really get the concept of this undefined. Guys, undefined means when any number divided by 0 is what we refer to as undefined. When you divide a number by 0, your calculator gives you this thing. That's error. Okay. So when you divide by 0 specifically, any number divided by 0, you get what we call undefined. Okay. This is different from something else. Okay. There are two concepts here. Undefined, which means division by 0. Okay. But then there's also another concept of non-real. Okay. That is when you have a even root and there's a negative number inside. Okay, when you have a even root and there's a negative number inside, we say that that is non-real, or we use the word imaginary. Okay, so for an example, if you took, for instance, the square root of -2, you put it in your calculator, your scientific one, you will get an answer. Because this is an even root with a negative number inside, you will get from your calculator the following: maths error. But please guys, this maths error does not mean undefined. It means non-real. Okay. So whenever you have a negative number within a even root, we say that that is non-real or imaginary. All right. So the maths error you get from your calculator for a negative number inside a even root, that's what means non-real. But a number divided by 0, that maths error does not mean non-real. It means undefined. So these are two separate concepts. Undefined means something different from non-real. Undefined means division of a number by 0. That maths error means undefined. But non-real has to do with a negative number within a even root. And guys, by even root, that means, let's say you had the fourth root of -7. That also is what? Non-real. Not undefined, but non-real. Why? Because this is an even root and within it there's a negative number. All right, so I repeat again, a number divided by 0 means undefined. Any number divided by 0 means undefined, whereas imaginary or non-real is when you have a negative number within a even root. All right, I hope that's clear for all of us. So going back to this question, given r is equal to the square root of 2x plus 6 over 2x minus 6, when they ask for which value of x will r be undefined, immediately in your head when they say undefined, you know that any fraction, whenever there's a 0 in the denominator, that's what undefined means. Or any number divided by 0, that's what undefined means. So if you go back to your r, you are looking at the expression of r, which is 2x plus 6 over 2x minus 6 underneath the square root. When they say for which value of x will r be undefined, immediately your attention gets turned into the denominator, which is 2x minus 6. Then what's your goal? To equate the 2x minus 6 in the denominator to what? To 0. And by so doing, you are able to then find the value of x by solving for x, the value of x by which this expression will be undefined, or in other words, by which r will be undefined. Okay, guys, I hope this concept is clear for all of you, because I want to move on and go to the next question underneath the sub question for this particular problem. Okay, so please let us not confuse these two concepts. Undefined means division by 0. Non-real or imaginary means whenever you have a negative number within a even root. And guys, even means 2, 4, 6, 8. So any even root means it could be the fourth root, it could be the square root, it could be the sixth root. As long as it is an even root of a negative number, we know that is called a non-real or imaginary number. Very, very important. This is non-real, but it requires a even root. Okay, let's move on to the next part. For which value of x will r be equal to 0? I repeat, for which value of x will r be equal to 0? So we come here, we want the value of x, okay, for which r will be equal to 0. So that's quite straightforward, because if they want the value of x for which r will be equal to 0, all we do, we are going to write down the expression good morning, and all we do is we substitute in the place of r0 and our goal is to just solve for who? For x. That's it. Okay, so in order to do that, we're obviously going to square both sides. Why do we square both sides? We square both sides so that we can get rid of the square root. Thank you, Ndoni. Definitely, we square both sides. When we do that, that leaves us with 0 is equal to 2x plus 6 over 2x minus 6. Okay, now we have what? A fraction equation. Okay, we have what? A fraction equation. But remember, 2x minus 6, okay, that means we are going to write down the LCD, which in this case, the lowest common denominator is 2x minus 6. Then we write down something that we refer to as a restriction, which means we want to check what x cannot be. Because remember, guys, x can never be. We want the value of x that will basically make r be equal to 0. We want that value of x. We want to ensure that no other values interfere with that. So in order to be able to do that, we know that the LCD, or the lowest common denominator of this equation, is 2x minus 6, because this is the only denominator that we have. All right, so the idea of cross multiplying, definitely okay, fine as well, but I want you guys to understand that the LCD is 2x minus 6. Our restriction, meaning we want that thing, that value of x by which x cannot be, because if x becomes something in the denominator, then we know we have a problem. Okay, yeah, Khalifa, I get your point. All right, but of course, by actually saying what I'm saying, I'm trying to clarify and make sense of something that the learners are going to still come across. So I get your point, but just making points that are important here so that I lay the foundation for something else that's to come. All right, so we know that here x cannot be 3. For instance, we already established that the value of x by which r will be undefined is when x is equal to 3. So we know that if we want x to be equal to 0, and that's the only thing we want, x can never be equal to 3, because if x is equal to 3, that will mean that our r value will be undefined. We want to know for which value of x will r be equal to 0. So we know that the restriction is that x cannot be 3. Okay, so if we take that LCD, we multiply by the LCD left and right, then that basically means that we are going to multiply by 2x minus 6 on the left, but we are also going to multiply by 2x minus 6 on the right. Okay, and then when that happens, the 2x minus 6 that we multiply by cancels out that 2x minus 6. We know that 2x minus 6 times the 0 will lead us to a 0. So what that leaves us with is 0 is equal to 2x plus 6. So as my good friend in the comment section said, Khalifa, that in this particular scenario, we could just simply take the numerator and equate it to 0. Because, why? Because we know that we need to indeed exclude the value of x that will make the fraction undefined, right? So x cannot be 3, but of course, after finding the LCD, writing down the restriction, we multiply both the left and the right by the LCD, which is 2x minus 6. That eliminates the denominator, which is 2x minus 6, because what we do on the left, we do on the right. And then ultimately, we can now go ahead and solve for who? We can solve for x. So when we do, we take the 6 over. That becomes a negative 6 on the left. Then what do we do after that? We divide both sides by the coefficient of x, which is 2. Remember, the coefficient of x is 2, so we divide by 2 on the right. But remember, what we do on one side in an equation, we must do on the other side in an equation. So what's negative 6 divided by 2, guys? That gives us a negative 3. So that's why we conclude that x is equal to negative 3. So for which value of x will r be equal to 0? Right? The value of x that will ensure that r is equal to 0 is when x is equal to negative 3. Because the concept is that any number, when 0 is divided by any number, when 0 is divided by any number, that's how we are able to get a 0. Thank you so much, Sakhamitzi, for the "you're awesome." I really appreciate it. So 0 divided by any number is equal to 0, which is why when we go back to what my good friend said, Khalifa, all right, let me just I just wanna when Khalifa was saying in that scenario you just take the numerator be equal to 0, that is basically the shortcut to how we would be able to go about answering this question. Okay, so let's relook at the question again. It says, for which value of x will r be equal to 0? So the concept behind that is that 0 divided by any number is equal to 0. So our focus then would simply be on the numerator. Okay, so to shortcut the process, we would simply just go to the numerator, take the 2x plus 6, and make it equal to 0, because as long as there is a 0 in the numerator, 0 divided by any number is surely going to give us who? 0. So instead of this long process that I've just explained here, which is I did it because I just wanted to make a point, all right, and this will help in later examples and in later problems that have to do with simplification of equation fractions. But to simplify this particular question, when it says for which value of x will r be equal to 0, all we simply do, guys, is we go to the numerator of the given fraction, take what is in the numerator, equate it to who? To 0. Why? Because 0 divided by any number will surely give us what? 0. And because it says for which value of x will r be equal to 0, that's what makes life very easy. We simply take what is in the numerator, which is 2x plus 6, equate it to 0, and then we would simply just solve that, and that would lead us to the simple answer of x is equal to -3 without having to actually really do this long process that I've just explained here. Okay, Kela, you're just going to have to really see when I go live, because I don't have a schedule at the moment. It's December, as people are saying in the comment section, so it's a bit crazy, but I will post the the recording onto my YouTube channel, so you can always watch it at your own time when you actually do have the time. All right. Okay, so guys, so far 2 important concepts. For which value of x will r be undefined? Remember, I said undefined means what? Any number divided by 0 means undefined. Okay, any number divided by 0 means what? Undefined. That's what undefined means, which is why with this particular question, what did we do? We took what is in the numerator, the expression 2x minus 6, and we took what is in the denominator, 2x minus 6. We equated it to 0 so that we could find the value of x that will make the denominator be 0, so that we can find the value of x which will lead to r being what? Being undefined, because we know that being undefined means any number divided by 0. This was the concept behind undefined. Now the second question says for which value of x will r be equal to 0. Now we want r being 0. What is the concept? The concept is that any 0 numerator divided by any number will mean equal to 0, which is why our focus this time round is not on the denominator, but it is on the numerator, which is what? 2x plus 6. And what we do to the numerator, we simply take it and we equate it to 0. Then we solve for x, and we get x is equal to -3. This is the value of x that will basically make r be equal to 0. So I hope, guys, so far we understand undefined means 0 in the denominator. the value of r being equal to 0 means 0 in the numerator. So with undefined, we took the denominator equated to 0 and we solved for x. For equal to 0, we took the numerator, equated it to 0, then we solved for x. I need you guys to really internalize these two concepts. The concept of undefined, which means any number divided by 0. Thank you, Sekhavetse, for the heart me. And the concept of an expression being equal to 0. Okay, taking the numerator this time round, equating it to 0, and solving for x. Okay, right, let's move on. Next beautiful question. If x is a natural number, hey, and you guys thought that going to grade 10, you would be fine not remembering your different types of numbers. No, guys, you need to know your different numbers. So it says if x is a natural number, what is the greatest value of x for which r will be non-real? Okay, so remember, r is the square root of 2x plus 6 over 2x minus 6. What is this thing saying? If x is a natural number, okay, so let's start here, guys. What is a natural number? Let's see if in the comment section you guys can remember. What is a natural number, guys? Natural number? Natural number, anyone? What is a natural number? Natural. What is a natural number? Thank you, Roland. A number that starts from 1. Good. Shai even gives me examples. 1, 2, 3, 4, 5, 6, 7, 8, and so we go. Guys, natural numbers indeed are numbers starting from 1. Let us never confuse natural numbers with whole numbers. If this question had said if x is a whole number, we know that whole numbers are different. Whole numbers are numbers that start from 0. Then they increase by 1 all the way to infinity. But natural numbers start from 1. Let us never confuse the two. So yes, they are saying if x is a natural number, what is the greatest? So we need the greatest. Greatest means biggest. Biggest means largest. Largest means greatest. Greatest means biggest. Biggest means largest. Mukhulu. Mukhulu. Big one. Greatest. So we want, they are saying if x here is a natural number, what is the greatest value of x? We want the biggest value of x, the largest value of x, for which r will be what? Will be non-real. For which r will be what? Non-real. Guys, what did I say to you earlier on about non-real? Non-real means what? By now, you guys should understand what non-real means. What does non-real mean in maths, guys? Non-real. Thank you, Roland. When there is a negative number, inside, guys, inside a what? A even root. Even. So Roland gave me a specific, a square root. Guys, a square root is even. a fourth root is even, sixth root is even, eighth root is even. All right, so for instance, this is an example. The fourth root of -3 is non-real. Okay, if you put this in your calculator, you'll get maths error. The square root of -8, for instance, is also non-real. Okay, so there are two things we always need to check with non-real. Firstly, is this a even root? Yes, it is. This is a square root, guys. Guys, just so you know, square root means this. If we were to reveal the number that is there, this is the number that is there. That's what square root actually means. There is a 2 there, but we don't usually write it out. Okay, so that's what square root means. Are we together? Which is why when you square a square root, then the root disappears. Okay, so let's be clear about that. All right, so whenever you have a negative number inside a negative number inside a even root, doesn't have to be a square root, it can be a fourth root, it could be a sixth root, it could be an eighth root, it could be a 12th root, 10th, as long as it is a what? A even root. Then we say that that is a non-real number. So what they are asking us here is they want the biggest natural number for which R will be non-real. Okay, that's what they want. So let us test this. Let's check the first natural number. What is the first natural number, guys, that we have in natural numbers? The first natural number is, because I want to test it out. Come on, guys, help me out here in the comment section. My first natural number, because me, I want the biggest one. Okay, thank you, 1. So let's take 1 and substitute it and see if we get a non-real number. 2 times 1 in the numerator is 2 plus 6. Okay, then in the denominator, 2 times 1 is 2 minus 6. Okay, what's 2 plus 6? What's 2 minus 6? What is going to be our answer? Okay, do you see that? This is non-real. So that means this natural number number 1, actually gives us a non-real. We want, if x is the natural number, what is the greatest value of x for which R will be non-real? Okay, 1 gives us a non-real number, but we don't know if it's the greatest. Let's look at the next natural number. The next natural number after 1, guys, is actually what? The next natural number after 1. Thank you, Ndoni. 2. Let's check 2 out. 2 times 2. Let's see what we get. We have 4 plus 6. Because remember, bed maths, we need to make sure that we do multiplication first. We can't add this. We need to do multiplication first before addition and subtraction. So 2 times 2 is 4 plus 6. Underneath we have 2 times 2 is 4 minus 6. Let's see if we get a non-real number. We have 10 in the numerator. 4 minus 6, we have negative 2 in the denominator. We get a negative 5 here, because 10 divided by negative 2, remember, positive divided by negative is negative, 10 divided by 2 is 5. So with the square root of negative 5, this is still non-real because this is a negative number underneath a even root. All right, so 2 also gives us a non-real number, but 2 is bigger than 1. So far 2 is the biggest number that I have. But let's check the next natural number and see, do we get a what? A non-real number. Let's see. 2 times 3 plus 6. Maybe you guys can finish it off for me and see, do we still get a non-real number? You guys confirm for me in the comment section. Let me just hold it right here for now. You guys can confirm for me. I want you to confirm for me if we still get a non-real number. Because remember, what is the question asking? If x is a natural number, what is the greatest value of x for which r will be non-real? Letu Twala says no. Okay. Ndoni says it's a real number. Very good. Okay. So let's just check it out. 2 times 3. 2 times 3 is 6. 6 plus 6. Okay, let's see there. 2 times 3 is 6. 6 plus 6. Denominator, we have 6 minus 6. Ooh, what's 6 plus 6? It's 12. What's 6 minus 6? It's 0. What is this, guys? 12 divided by 0. We call this what kind of number? Now I need to see if people actually remember, what do we call this number? Thank you, Sekhametsi. Sekhametsi, you are amazing. We call this a undefined number. It's not non-real. We say it's undefined. There's a difference, and we explained the difference, guys. We explained the difference. Those who are asking me, is this grade 11 work? Is it what? Guys, remember, this concept of the question that I'm asking and these concepts, they are relevant to all grades 10, 11, and 12. Okay, obviously foundational to the grade 10s who I am focusing on, but very important for a grade 12 and a grade 11 learner to not forget the concept of non-real and undefined and what they mean. So yes, undefined. So can we say that 3 is one of the natural numbers, as it says here? If x is a natural number, what is the greatest value of x for which r will be non-real? When x is 3, is r non-real? Is it? Could we enlist 3 as one of the natural numbers? That will give us non-real. Thank you, Ndoni. Ndoni says no. Right. Okay. But when x is 2, is r non-real? Okay. The last time, guys, we had a non-real answer or non-real for r was when x was actually equal to 2. All right. So if we are going to now answer the question, if x is a natural number, what is the biggest, greatest, largest value of x for which r will be non-real? Thank you, Survivor. It seems, and I would suggest that indeed it's when x is equal to 2, not when x is equal to 1. It's when x is equal to what? 2. That is the greatest value of x for which r will be non-real. Guys, remember, the question could have been asked differently, and they could have asked maybe, if x is a natural number, what is the smallest? Had they said, if x is a natural number, what is the smallest value of x for which r will be non-real? Our answer would have been completely different. We would have said x is equal to what, guys? If x is a natural number, what is the smallest? Yes, Ndoni, it would have been 1. But because they are saying if x is a natural number, what is the greatest? We then said x is equal to 2. We conclude that therefore x is equal to 2. So by mere trial and error in this particular question, we were able to arrive at the answer. Okay. And for me, what is important here? For me, what is important here is your understanding the relationship between the numbers and understanding the concept of undefined. What does undefined mean? Any number divided by 0. In a fraction, when you have a 0 denominator, that's what undefined means. In your calculator, you get maths error, but any number divided by 0 means undefined. What does non-real mean? Non-real means any negative number inside a even root. For example, the square root of -2, the fourth root of -7, the sixth root of -8. These are all non-real. So we are talking about a negative number housed within an even root. What about when we talk about, what is a natural number? We need to understand what a natural number is. Okay, let's look at another question underneath the same thing. If x is a prime number, what is the smallest value of x for which r will be rational? I repeat, if x is a prime number, what is the smallest value of x for which r will be rational? Now, you see, and you guys think your definition of numbers is not important. Your guys' definition of numbers is so freaking important. You guys need to know your numbers. So what is a prime number? Do you still remember what a prime number is, guys? Hey moms, I mean, like, can't do people write on my exams this season about family? Hey, there are serious people, moms. There are serious people in this world. Yeah, so allow them to be serious. If you want to have a good time with your family, please don't allow yourself to be harassed. Go and have good times with your family, but there are serious people here. These people, they want to do well, so allow them to. If x is a prime number, guys, what is a prime number? By definition, prime number, do we still remember? Prime number is a number that has only two factors. That has what? That has only two factors. One and itself. What are those numbers, guys? Give me examples of prime numbers. What is the smallest prime number that we have? Prime number is a number that has only two factors, one and itself. So think about numbers that have only two factors, one and that particular number. Thank you, Sekhamid. The smallest prime number is 2, followed by who? Followed by who, guys? Okay, so I love that. Smallest prime number. We have 2, good, Chloe, 3. 4 Ndoni is not a prime number. Remember, 4, if you look at the factors of 4, you have 1. 1 goes into 4 how many times? 4 times. You have 2. 2 goes into 4 how many times? Twice. So here already 4 has how many factors? 1, 2, and 4. There are 3 factors. So this is not, 4 is not a prime number. So yes, 2, 3, 5, 7, 11, 13, 17, 19, 23, and so it goes. So let's be careful. All right, Chloe, I don't know when I'll be going live for grade 11. I'll just have to see. Okay, like I said, just make sure you light on all the notifications that need to notify you when I go live in this particular channel, because this Maths is a Game channel is only dedicated to the grade 10s, 11s, and 12s. So when I go live here, you must know that everything that is being done here is relevant to a grade 10 foundationally, but 11 and 12 as well, because funny thing is you guys forget this theory that I'm doing here that has to do with numbers. You forget these things, and these are the very things that come back to bite you in your own papers, because you think that the only thing that is relevant is what you are doing in your grade, and then you forget the basics. Yes, guys, a prime number is a number that has only two factors, one in itself. So this is some of the prime numbers that we have here. What are they asking here for here? They are saying if x is a prime number, remember x here, what is the smallest value? So we want the smallest value of x. The smallest value of x for which r will be rational. Now let's go back here. What does rational mean? What is a rational number, guys? Do we still remember the definition for a rational number? Very important, by the way, to know what a rational number is. Okay, a rational number is a number that can be written as a fraction, guys, where the numerator and the denominator, as you have said, are both integers. Numerator is an integer, denominator is a integers. But remember, our denominator can never be equal to 0. I repeat, our denominator can never be equal to 0, because the minute the denominator is equal to 0, what do you remember again, guys? The minute the denominator is equal to 0, what is the problem there? We say that that number is not a rational number, but it is. And that's very important for us to never forget that. So yes, your numerator can be an integer, your denominator can be an integer. Now I'm going to ask you, what is an integer? Do you remember what an integer is? Yes, undefined, when the denominator is 0. Integers are both positive and negative whole numbers. So if you have your whole numbers 0, 1, 2, 3, 4, 5, 6, your negative numbers as well, by extension, negative 1, negative 2, negative 3, negative 4, negative 5, we are increasing and decreasing by 1. These are our integers. All right, so integers are positive, your natural numbers 1, 2, 3, 4, 5, your 0, including your negative whole numbers, negative 1, negative 2, negative 3, negative 4, all the way to negative infinity. So from negative infinity to positive infinity, increasing and decreasing by 1, those are all our integers. Okay, all right, so it's very important. There are no decimals there, no decimals, just positive and negative whole numbers. All right, increasing and decreasing by 1. So very important. So if you are starting at, if you have 0, your positive side 1, 2, 3, 4, 5, your negative side negative 1, negative 2, negative 3, negative 4, all the way to negative infinity. So that's very important. So concepts are important, guys. Do you see? So let's go back. If x is a prime number, we know what a prime number is. We are so clear about what a prime number is. What is the smallest? Guys, hopefully you guys understand what smallest means. Smallest means your lowest number, you know, your lowest of the lowest. So if you're looking at your prime numbers, we are looking for the smallest number, the smallest prime number, which will be in the place of x, for which r will be rational. Okay, right. So let's check our trial and error game again. Remember, we know, or we remember from the previous question, we did substitute 2. Remember, when you substituted 2, we didn't get a what? A rational number. We got a non-real number. So I'm not going to waste my time and substitute 2. I know what 2 does. It gives me non-real. I substituted 2. Doesn't work. Substituted 3. Remember, when I substituted 3, I got an undefined number. Okay, I won't forget, don't worry. So these 2, I know are not going to help me with anything. Okay, yeah, so the 2 did not give me a rational number. The 2, when I substituted it, gave me a non-real. So 2 is not the smallest prime number. 3 as well, when I substituted it, gave me an undefined number. It is not going to be the number that is the smallest prime number. which will give me a rational number. So I'm going to have to go up my list and check 5 out. Let's go and check 5 and see with the 5. 2 times 5 plus 6 over 2 times 5 minus 6. Okay, do you see, guys, how I quickly eliminated 2 and 3 because of my previous answer or my previous response to the question that had been asked before? So now 2 and 3, I'm not bothering myself. I'm going to go straight to 5 and check. 2 times 5 is actually 10 plus 6 over 2 times 5 is 10 minus 6. What's 10 plus 6? 10 plus 6 is equal to 16. What's 10 minus 6? That's equal to 4. If we take the square root of 16 over 4, guys, 16 divided by 4 is 4, and the square root of 4 is 2. What kind of number is this? What kind of number is this? Is this a rational number? Is R a rational number here? Is it, guys? Is this 2? Can we term it as a rational number? Yes, Sehamit, thank you. 2. Yes, 2 is rational because 2 can be written as a fraction, which is 2 over 1. So yes, if we go back to the definition of what a rational number is, a rational number is a number that can be written as a fraction, where the numerator is an integer, when the denominator is also an integer. 2 is definitely rational. So therefore that means our smallest prime number, the smallest value of x, which is a prime number for which R will be rational, it's when x is equal to what? To 5. That's it. That's it. Done, dusted. Okay. Hey guys, I hope we are good here. I hope we are good. I hope we are good. Okay. That was nice, wasn't it? Alright. So guys, why is this important? It is important because in your first term for grade 10, when you enter that pure maths class for the very first time, one of the very foundational things you need to be reminded of as a grade 10 learner is the importance of the number system. Thank you so much, Sehamete, for the finger heart. Really appreciate it. The importance of the number system. You guys need to know the number system. You need to know it so well. Right, guys? I'm just going to, for a moment, check here with you. I want to check here. This symbol in the number system, what does it stand for? I want you to tell me. What does this symbol stand for in the number system? I want to see if people know their stuff. How important it is to know this. How important it is to know this. What does this symbol stand for, guys? Thank you, Sehamid. Natural number. You guys need to know this. You need to know it. And then after that, you need to know the definition of what a natural number is. It's not good enough to just know the symbol, but you need to know the definition of a natural number. Okay, you guys explained it well earlier on, that a natural number is a number that starts from 1. We then increase by 1 all the way to infinity. Right? That's very important. Very, very important. Okay? Right? So this is a symbol that is used a lot in maths, and this means element. And all that means in English, it's like saying natural numbers is this is just an English way of saying natural numbers are or is. This is like an are or is in English. Okay, so the word element means is or are. This is English interpreted into English. Natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this word element, this symbol element, simply means in English is or are. However you want to look at it. Okay, I mean just in layman's terms. Okay, all right, so you guys know what natural numbers are. Let's look at another symbol, this one. Aye, guys, we need to be well versed in this. This one, what does this one stand for? This symbol, this one. Alright, guys, just tell me in the comment section whole numbers. Thank you. Whole numbers. Whole numbers. Dango, whole numbers. Alright, and all we know and we appreciate about that, okay, is that unlike natural numbers, whole numbers start at 0. Start from 0, increase by 1 all the way to infinity. Okay. Alright, let's move, guys. Let's move. This one, this symbol. You see, maths is a language, guys. Maths is a language. It's crazy that these things have meaning, eh? And the funny thing is, many kids, oh my goodness, they do pure maths and they don't know the basics of these things. And then they, hey, don't cry for me, Argentina. Thank you. Integers. What are integers? You see, what are integers? The definition of integers. All right, very important. You guys need to understand what integers are. All right. All right, and this is just to show that there are many numbers from negative infinity all the way to positive infinity, but we are moving, we are increasing and decreasing by 1, guys. Why is Z for integers? That's a very good question, Survivor. Maybe you can survive this live and then you can actually go and find out why Z. I absolutely have no idea why it is that they're using these kinds of letters. But remember, guys, that mathematics, much of the mathematics is coming from the alphabets and the symbolism from the Romans, from the Greeks, your Greeks and your Romans. So maybe sometimes you'll find that certain notation is symbolic of what the Greeks or the Romans, you know, because they were the ones they were the people that were thinkers of the time, and basically documented and wrote down. Maybe, who knows, maybe the Zulus or the Tswanas were discovered these things also a long time ago. But the thing is, Tina, we are not writers. We preserve our history through oral. We speak our history. We don't write it down and preserve it somewhere, you know. Or maybe we were sabotaged. I don't know, you know. So go and look it up. Go and check it out. I'd love to know. And Survivor is like saying, yes, it is a symbol, but why is that symbol when N makes sense? I understand you. I hear you. But us Tswanas don't have Z in our language. Yeah. But guys, like I said, that's the symbol that they decided to utilize. Okay, so go and check it out. Go and do your own research. Okay. And maybe historically you can let me know. Maybe Survivor, you can do a post on your TikTok and then you can tag me in your post once you've figured it out as to why. Maybe you can do a whole video on it, eh? Yeah. Okay, 4. All right, let's move on, guys. Q. The Q symbol, what does that stand for, guys? The Q, what does it stand for? It's not irrational. Not real. This means rational numbers. Please guys, let's not forget that rational. Okay, the irrational one is the Q with an apostrophe in it. That Q with an apostrophe means irrational. Okay, so a Q means rational. A Q with an apostrophe means irrational. Guys, what are rational numbers? Let's not forget that rational numbers are numbers that can be written as a fraction. Primarily, they can be written as a fraction where your A and your B, both of them, your A and your B are integers. Do you see this thing? Your A and your B are elements. So once again, this symbol of element, your A and B need to be integers, but we know that the B, and please guys, this is another symbol, B cannot be, this means B is equal to 0, but the minute you say B with the equal sign and then you put a vertical line across the equal sign, it means B cannot be 0. So we exclude the 0, all right, in the denominator, but A and B can be any integer. The numerator and the denominator can be any integer, all right, but B cannot be 0. So rational numbers are numbers that can be written as a fraction where the numerator and the denominator are integers, but B cannot be 0. Make sense? Sorry guys, bless me as well. So very important, that's what rational numbers are. Okay, and then of course there's many examples that you could write. 7/4. We just saw one, the square root of 16/4, because when you simplify this, it can be written as a fraction. Okay. Oh, look at this survivor. Z for integers comes from the German word Zahlen, which means numbers. Wow. Yes, thank you so much. You see this? You see? Now survivor, that's what I call interest in the subject. You see, when you can take it up that far, okay, that is very insightful. Zahlen, which means numbers. Okay, and it's German. Well, you look at that. You see who's getting the credit here. Okay, now we understand where that comes from. Thank you so much. Thank you so much. Yeah, survivor. That was really. Look at you, hey, like so quick, hey, so quick on your fingers there. And this is what helps an individual have interest in that particular subject that they are doing. When you go above and beyond, and you simply don't just stick to what is in the textbook, and you try and really get yourself educated above and beyond, then you see there's more chances that you will never forget what an integer is, because you went the extra mile and you found out more. So thank you so much for that though, really insightful. Yes, so those are our examples, guys. Examples. All right, we know that we can't have 0 in the denominator, so we need to always be mindful that even if it's a fraction but there's a 0 in the denominator, it can't be rational. Okay, then remember guys, we have 2 types of decimals with your rational numbers. 2. They are what we call terminating decimals. Okay, the word terminate, I don't like using this example that much, but sometimes I do. Okay, to all my young girls, I hope you never find yourself in a situation where you have to terminate a pregnancy because you had a child or you had a baby when you were not meant to have one. I don't think that's a nice experience to ever go through, but I use this example so that I could make the point. When you terminate something, you end something, you bring something to an end. All right, so if you are looking at a terminating decimal, for instance, the fraction 7/10 can be written as 0.7. Firstly, this is a fraction. The numerator and the denominator are integers. When you convert this fraction into a decimal, it is actually a terminating decimal. Right? Why? Because 0.7 does not go beyond the first decimal place. It's 0.7. It stops there. Right? So whenever your decimal stops, we call that a terminating decimal. All right, it could stop at the second decimal place, meaning it can be rounded off to second decimal place, third decimal place, fourth decimal place, fifth decimal place. It depends. Okay, that's what we call a terminating decimal. Or the second type is what we call a recurring decimal. What do we mean by recurring? Okay, does that make sense, guys? So 0.7 with a dot on the top, that means the 7 repeats. So it's like 0.7 and it's 7 forever. Okay, hence I usually refer to it as not just recurring but infinite recurring decimal. Why infinite? Because this pattern will repeat itself forever. Or if it does not have a dot on the top, okay, we can have a 1/8 with a line on top of the 1/8. Okay, Shai is asking, sir, can I ask, so are we terminating which number? Like I was saying to you, when it comes to decimals, your rational number can be expressed in one of two ways. The first way is a terminating decimal. So in other words, the word terminate means there's a stopping of numbers after the comma at some point. Okay, so for instance, with 7/10, there's 0.7. You don't see any more numbers after 7. It means that we stop at 7. That's where we are stopping. Okay, let's just say we had 127/1000. This would be 0.127. So once again, okay, let me just change this because people are gonna think that it only terminates when there's an 7. So for instance here, this is 0.128. Okay, 128/1000 can be written as 0.128. What does that mean? We are now terminating at the third place. Does that make sense? So we round, this is third decimal, first decimal, third decimal. All right, we terminate at the third. Here we terminate at the first. We stop at the third decimal place. We stop at the first decimal place. That's what I mean by terminating decimal. There's no other numbers after the 7. There's no other numbers after the 8. Okay, so that's what I mean by terminate. Okay, it's like a rounded off value. The minute you round off a value, it's like you are terminating it. Okay, so rounding off numbers is a way of writing a certain number to become terminating. I hope that makes sense. Okay, so please, Clay, just confirm for me that you are clear about terminating, so that when I move on knowing that you are clear. Yes, limited. That's another beautiful word you can use. Limited. Very good. I love that word even. Terminating can also mean limited. Very, very nice. I like that usage of that word. Okay. Love it. Okay. Yes. Okay, are we good now? All right. Okay, then recurring decimal. So your second type of decimal underneath rational numbers is your recurring decimal. So for instance, 0.7. The minute you put a dot, you are meaning the 7 repeats. Or you could put a line over the numbers that repeat. So for instance, 0.18 would basically mean that 0.181818 and so it goes. Whereas here 0.7 means 0.77777 and you put dots to indicate and so it goes. Alright? These are what we call infinite recurring decimals. And trust me guys, these can also be written as a fraction. So for instance, 1/3. Okay. Thank you, Survivor. That's very true. I'm glad you understand this, because this is the thing. You're losing unnecessary marks, unnecessary. All right. Yeah. All right. So there, 1/3. If you take your calculator, you punch in 1/3 and then you press that button in your scientific calculator that is SD. You are going to see that it actually converts that fraction for you into a decimal, and you see that, oh, it is actually a recurring decimal. Okay, so from a fraction, a rational number, as it says by definition, is a number that can be written as a fraction where the numerator and the denominator are integers, but the denominator can never be 0, right? So when we look at decimal numbers for your rational numbers, there are two types. There are terminating decimals, which I've explained what they mean, and there are infinite recurring decimals, and I've explained what those actually also mean. All right, and then let's go on now to irrational numbers. Irrational numbers are numbers that cannot be written in this way. All right, they can't. All right, they can't be written as a fraction where the numerator and the denominator are integers and where the denominator cannot be 0. They are not, they are the opposite. So the opposite of rational is irrational. Opposite of rational. And if you look at like the square root of 2, for instance, pi in your calculator, pi in your calculator, these are all examples of irrational numbers. Why? Because if you look at the decimals, they are non-recurring and at the same time non-terminating. In other words, there is no repetition and there is no pattern. No repetition, no pattern. No repetition and no pattern that exists, and then non-terminating means they don't stop. Okay? They don't stop. But the thing is, you can't predict what the next number will be because there's no pattern. Okay? So for instance, if you take the square root of 2, you put it in your calculator, you can see that there's no repetition of a particular pattern of numbers. And if you were to actually be given a chance to open your calculator and see all the other numbers that come afterwards, you would see that those numbers are basically numbers you would have never predicted because there's no pattern. Okay, so those are irrational numbers, guys, and that's very important to be able to distinguish between these two. So when something is rational, it can't be irrational. And when something is irrational, it can't be rational, because these are opposites of each other. It's like black can't be white and white can't be black, guys. Does that make sense? So you can't say when something is rational, you can't say it's also irrational at the same time. It doesn't make no sense. Okay, all right, very important as well to note that. Okay, yeah. And so there's always these questions that usually get asked between which two consecutive integers does. Okay, and these are common questions that get asked. You need to find the two integers that follow each other where the square root of 7 actually lies. All right, and I'm sure when you were in grade 9, these were questions that were commonly asked, and these are questions that get asked even here in grade 10. Between which two consecutive integers does the square root of 7 lie? The square root of 7 is an irrational number, so they usually ask, where does this irrational number, between which two consecutive integers does that particular irrational number, where is it found? Okay, so you usually need to write a perfect square that immediately comes after 7 and a perfect square that comes immediately before 7. Do you guys know what a perfect square number is? Guys, perfect square numbers are numbers such as this. I'm just going to show you by example. Explanation can come later. Okay, these are numbers you should know. 1 is a perfect square number. You multiply 1 by itself, you get 1. 4 is a perfect square number. You multiply the next natural number 2 by itself, you get 4. 9 is a perfect square number. 16 is a perfect square number. That's what I mean by perfect square numbers. So the way we usually actually go about answering these questions is that we write the perfect square number that immediately comes after 7 and the perfect square number that comes immediately before 7. So after 7, if you think about a perfect square number that comes after 7, think about it. It's not 1, it's not 4, it's 9. Then you think about a perfect square number that comes before 7, it is not 9, it is 4. Remember, this had a square root. So go ahead now, you can house each number in a square root. What happens with the square root of 4? That becomes 2. What is the square root of 7? That remains. Square root of 9, that is 3. Then you conclude the square root of 7 lies where? Lies between who? Between 2 and 3. And that's that. Done, dusted, easy. So all you need to do is you need to find a perfect square number that is greater than the given rational without its root. Okay, or really and truly, and then you put your inequalities there. You put an inequality sign. Remember, what do these inequalities mean? It means the square root of 7 is greater than the square root of 4 but less than the square root of 9. I repeat, the square root of 7 is greater. Mouth opened towards the square root of 7, it means this is greater than this. So the square root of 7 is greater than the square root of 4, which makes logical sense. Logically, guys, the square root of 7 is a number that is greater than the square root of 4, but it's less than the square root of 9. Makes sense because this is found in between these two numbers. So you find a perfect square greater than 7, remember, without the square root. Remember, initially I put 7 on its own. I wrote down a perfect square number after 7, a perfect square number before 7, and that was 4 and 9. Then I housed each underneath its square root. Then I worked it out. Square root of 4, 2. Square root of 9, 3. 2 and 3 are these numbers that are consecutive. Remember the word consecutive, one after the other. 2 is followed by 3. Make sense? So these are consecutive. Square root of 7 lies between 2 and 3. So if you were in a number line, that would mean you'd have 2, which is an integer, 3, which is an integer, and an irrational number that is found in between these two would be One of them would be the square root of 7. There are many irrational numbers here, many, but 2 and 3 are what? They are integers. They are not only integers, but they are also what? Whole numbers. They are not only whole numbers, but they are also what? Natural numbers. They are not only natural numbers, but they are what? Whole numbers. They are not only whole numbers, they are what? Integers. Does that make sense? And they are not only integers, but they are also what? Rational numbers. But they are not irrational. But inside, between these two numbers, is found the square root of 7, which is the irrational number that we were actually checking as to where it lies. Okay, so I hope that makes sense, guys. So all in all, these are typical questions that get asked, you know, which you need to also be very much aware of and you know, very well versed in. Still on symbols, what does this symbol stand for, guys? The R. Haha, Dinswalo, how can you say rational, man? Come on. Guy, this too was rational. What do you mean it's come on, Dinswalo. Thank you, Dinswalo Makubela. R means real number. Do you know what real numbers are, guys? Real numbers. What are real numbers? All the numbers in the number system. Rational and irrational. Okay, does that make sense? They cannot be undefined and they cannot be non-real. They cannot be undefined or non-real. Okay, remember, undefined, number divided by 0. Non-real, negative number inside a even root. Okay, then the last symbol is this one. What does this symbol mean? Thank you, Dinswala. Non-real. Okay, I think we are good, guys. Yeah, you guys got me to 19.5k likes. Thank you so much. Hey, this is very much appreciated. Non-real. Okay, and remember, non-real numbers, these are all the negative even root. All the negative even number root. So for example, negative 5 to the power 6, to the 6th root, negative number inside a even root, we say that's non-real. Okay, guys, is 6 over 0 also non-real? My question to you, 6 over 0, is it non-real? Is 6 over 0 non-real? That's my question to you. 6 over 0, is it non-real? Is it? No, thank you so much. 6 over 0 is not non-real, it is undefined. Guys, undefined, as I explained to you, is division, number divided by 0. That's undefined. Non-real is different from undefined. Non-real means any negative number within a even root. Please, guys, let's not confuse the two, because if we dare confuse the two, that's where the problems start happening. Undefined means a number divided by 0. That's not non-real. Non-real, on the other hand, any negative number inside a root that is even. 2nd root, 4th root, 8th root, inside a negative number, we know that is a non-real number. Okay, guys, I feel like I've fed you a lot. You know, it is your obligation and your responsibility to make sure that with the feeding that you have just experienced, you make sure that you do not have misconceptions or confuse stuff that is here. Furthermore, I want to add that you need to also know how to convert a recurring decimal into a fraction, and I mean literally by way of solving, how to convert. I think in this video let me just conclude on that note. Let's say we were asked to show that this is a rational number. Now someone will say, but it is, and I'm like, but how? And they're like, but it is, and I'm like, but how? And then they're like, but it is, and I'm like, but how? And they're like, well, there's a line over 7/5, that means it's recurring. But I'm like, but that doesn't help me with anything. I want you to show me that this is a rational number. So what we do is we let x be equal to 0.75, and we write it out 7575. We know that 75 repeats infinitely. We're gonna say that's equation 1, right? Then what I do is I'm going to actually form a second, third, fourth, fifth, sixth equation by using multiples of 10. Take this equation, I'm gonna take x on the left and I'm going to multiply it by 10. What I do on the left, I know, guys, I will do on the right. If I multiply by 10 this side, I get 10x. I multiply by 10 here, it means I move the comma once. That means I get 7,57. Okay, makes sense? And it repeats. But the only problem is, when I have my other equation, the goal is to ensure that after the comma, the decimals are the same. As you can see here, this is 7.5, this one is 5.7. The decimals are not the same. That's a problem. So I'm going to actually look at my other multiple. Multiply the x here by 100, not by 10. When I multiply by 100, that means I move the decimal how many times to the right? 2 times. So I'm going to now have 75, comma. Now, the minute I move it twice, it means 75, comma. What is coming afterwards? 7,5,7,5,7,5, and so it goes. That's my third equation. Guys, let's just throw another equation. Let's just multiply by 1,000 as well. Hey, let's just do it because we just have the time. All right, just want to show you something here, guys. If you multiply by 1,000, multiply the same equation, multiply the left hand side by 1,000, what happens? We get 1,000x. But when you multiply by 1,000 here, it means we move the decimal how many times? 3. 1, 2, 3. That means 757, 757, comma. Now 57, 57, 57, 57, 57. I now have equation 4. Guys, do you see how many equations I have? Now, listen. Okay. I just want 2 equations. I'm gonna say, I just want. Happy birthday, Beyonce, Beyonce. I just want the same decimals after the comma. All I just want are the same decimals after the comma, after the comma. I just want the 2 equations. I just want two what? Equations that have what? That have same decimals after comma. That have same numbers. Let's just say have same numbers after the comma. Just the 2 equations. Which 2? Look at this. So if you look at equation 1, I could take equation 1, 7.5 after the comma. Which else has 7.5? This one doesn't have 7.5. This one has 7.5. So these 2, 1 and 3, I could take. Right? Let me just show you that. So 1 and 3. and we're going to say equation 3 minus equation 1. We take the big one minus the small one. So in other words, that means 100x over this x Okay, do you see this, guys? 100x. Or on the other hand, I could take equation 2 and equation 4. Right? Why equation 2 and equation 4? Look, after the comma with equation 2, I have 5, 7. After equation 4, after the comma, I have 5, 7. So I could take that as well. I'm just going to show you guys that at the end of the day, I'm going to get the same what? The same answer. So let's just say 1000x is equal to 75,7. 1000x is equal to 757, 4, and then here equation, so that's 4 minus 2. 1000x, okay, 2, 10x, 7,5757. Okay, so let's first check equation 3 minus equation 1 and see if we get the same answer here. So on the left, we subtract 100x minus x. What's 100x minus x, guys? 100x minus x. I want you to tell me what's 100x minus x. That gives me what on the left, because I want to write down what. Thank you, Tinswalo. So it's 99x. Then we go to the left hand side, the right hand side. 75,75, 7575, 0,7575. So this one, 75 minus 0. Remember, you see why I say as long as the numbers after the comma are the same, because 7 minus 7 is 0, 5 minus 5 is 0, 7 minus 7 is 0, 7 5. So all these cancel each other out, and what I'm left with is a 75, which is what I want. Because remember, what is a rational number, guys? A rational number can be written as a fraction. Then what do? I divide both sides by the coefficient of x, which is 99, and then I get x is equal to 75 over 99. Okay, you take your calculator and you check, does this get simplified any further when you take your calculator? 75 divided by 99, you press equal, you check, do I get a more simplified fraction? If you do, write the final answer. If you don't, you leave it like this. So I want someone to tell me in the comment section, yes, if divided by 3, we get what? What's the answer, Sekhamit? When you divide it by 3, what do you get? So that's all well and good. If you're saying if divided by 3, okay, I'm going to wait for you to actually let me know in the comment section. When I check, it goes back to the recurring decimal. Yeah, if you press ST, it should go back to the recurring decimal. But those who have a scientific calculator, you should be able to put 75 divided by 99 and press equal. When you press equal, your calculator should give you a simplified version of the answer. Okay, so guys, please, if you are compromising which calculator you are using, please make sure when you start school you get a Casio calculator to use. Your latest version is also fine. I believe there's also the infamous white calculator, which seems to do more than just your normal ordinary Casio calculator. If your parents can get you that, guys, even for Christmas, that is the best calculator to have for grade 10, 11 and 12 moving forward, because it does a lot more things than ordinary. Okay, there we have it. Okay, you see, I used equation 3 and 1. Okay, when you punch this into your calculator and you press SD, it should lead you back to what? To this. You should see this recurring decimal, because you have just shown that this recurring decimal can be written as a fraction, and you've shown through steps. This is what they need you to do when you are actually showing that a particular decimal, recurring decimal, can be written as a fraction. They need you to show these steps, okay, letting x and so forth. Let's look at equation 4 and 2. Remember, equation 4 and 2 also have the same decimals. They are different, but let's see if it leads us to the same answer. What's 1000x minus 10x? What do we get on the left? 1000x minus 10x, that gives us thank you Tinswalo, 990x. Okay, we go to the right hand side. 757 minus 7. Remember, this 5757, this will all fall away because 5 minus 5 is 0. This will basically lead us to a no decimals, which is what we want because we want integers. All right, thank you 700 and what, 50. Good, not x. Be careful. 750, there's no x's this side. Okay, 750, you were right. Sekhamit was very right there, but please avoid that. Then what do we do after that? We divide both sides by 990. No problem. And then 750 divided by 990 should be able to actually lead you, when you simplify it, to the very same fraction, which is 25 over 33. Makes sense? Okay. Do you see? Okay. The whole objective of problems such as this is to first make sure that you write out that decimal the way that it has been expressed. Please guys, please. Okay, because there's times when there's, for instance, a question like this, 0.12, they put the dot on the 2 only. Guys, this means you need to let x be equal to 0.12222. It's the 2 only that's repeating. That's what that means. You see, then you multiply by, then you set up other equations, and then you make sure you take the 2 equations after setting up the ones that have the same numbers after the comma. Guys, as long as you get the concept, I don't care what question they ask, you should be able to answer the question. All right, there's one that usually tricks a lot of students, and this is this one. Okay, learners don't know how to actually write out this as a decimal. Remember, if there's a dot, if there are 3 numbers after the comma, there's a dot for your first number and a dot for your last number. What this means is that you let x be equal to, what does this mean? It means 1 to 1 repeats. That's what it means. Okay, 1 to 1, 1 to 1, 1 to 1 repeats. The 3 digits 1 to 1 repeat themselves. Okay, that's what that means. So I need you to understand that, so that when you do problems, you are able to do them in a way that is fitting. Okay, guys, that's it. I did not have much to come and bring here today. I just had this to bring to you, just so that I can get you guys warmed up for grade 10. Warmed up for grade 10, guys. Grade 10 is grade 10 pure maths. Grade 10 pure maths people, guys. This grade 10 maths is very nice, very sweet. All right? Yeah. Then I mean, you guys get into products. You get into like, this is. No, they won't fail hard. You are speaking rubbish, Cloudy. Cloudy, you need to go back to the hole. You need to go back to the hole where they fetched you. No, that's rubbish. Cloudy, if you are someone who has already done grade 10, and maybe you had an experience where you did not prepare early, right? Last year, my experience is I had a lot of grade 10s come into my live sessions last year, 2024, preparing for 2025 grade 10, and most of them, they did very well in term 1. I am not gonna lie to you, they joined the live lessons, they did very well in term 1. They shocked themselves with how well they performed. because they prepared early. They were in the live sessions when I was doing them, and it really helped them a lot. So easy distinction grade 10, but you need to make sure that you do your part. You need to make sure that you are doing the maths. You need to make sure that you are practicing. All the terms can be that way, but it needs someone to be consistent in what they do, because if you're not consistent, then I mean really and truly you're just signing up for a disaster, to be honest. Okay, that's not only term 1, cloudy, all terms. In fact, maths grade 10, 11, 12, it just needs someone who is working ahead. Guys, the only way to do very well in mathematics is to work ahead. Work ahead, be ahead of the syllabus. Do not be in line with the syllabus. Don't wait for your teacher to be covering things before you do them. Do them way before. You guys have resources at your fingertips. Grade 10, 11 and 12, all of you have resources at your fingertips. You have YouTube channels for days. How many TikTok videos have you watched of people testifying that Kevin Maths and Science helped me, Miss Angler did this, help me. Guys, these people have YouTube channels for days, man. There are live lessons being run on this platform like insanely. There's so much help to be had. Like, there's so much help that is available to you guys. Never in the history of this, this existence in our South African context have we had so much help that is available. So if you are lazy and you don't care, you are going to obviously butcher it, and you're going to fail bad. You're going to fall flat on your face. That is the truth. If you are lazy and you don't care and you just are mediocre, then of course you are going to get mediocre stuff. But I can promise you now, those people who are waking up every morning, there are people who are doing stuff like, man, there are people who are working so hard, it's insane. All right, so please, man, like, don't be lazy here. Don't be lazy. Yeah, well, if you are lazy, you'll sell yourself short. I think let me end this live and let's see if we can't start up a grade 11 live lesson just now. Let me end this grade 10 live so that I can save it and upload it for those kids that did not join in. Guys, my YouTube channel is still very much available and working. So this live lesson, for instance, that I did for the grade 10s, I'll basically be saving it and then I'll upload it onto the YouTube channel. You can watch it at any time, whenever you feel like you need to. But yeah, if you're failing mathematics, you're failing because you want. Sis,